Hello. I think there was a problem with the network. Who is there? I don't know how to go back to the other stream. Kindly, thank you so much. There was a problem. I was fixing my network. Sorry. Can we come back this side? I fixed it. Sorry for that. There was a problem with my Wi-Fi. It has never disappointed me. I'm sorry for that. Sorry. Please, let's log in here so that we can continue. Sorry for that. I was fixing my Wi-Fi. It had some hitches, huh? It has never misbehaved like that. I'm so sorry. Let's all move to this side, please. Sorry for that. I'm so sorry. Just tell the other ones to come. And Izzy, please tell them to come this side. I'm sorry for that. I was fixing my Wi-Fi. It had issues. I think it had some hitches. You know, the things which are made by human beings are prone to errors at times. I'm so sorry. So let us come to this side. I know we were already at 90 because I want to take 1 hour. Good. Thank you so much. Let's come this side. It was itches of my Wi-Fi. So as we come in, I was explaining much on the position of the centromere, classifying those chromosomes based on the position of the centromere. Kindly, let's log in. Tell the other ones, please. Let nobody miss. Just tell them to migrate to this end. I'm not the other side. I'll fix it this side. I've even opened a new stream. I don't know how to go back to the other one, so it's fine. We shall manage. So I was talking about submetacentric. Above the middle, a bit slightly above the middle part or the central part. So draw it showing very well the positions of the arms. And then you talk about acro, towards, the word towards the end makes the difference. And then draw it. The other arm is too short and not easy to see, but it's still visible. And then telo, it's to the end, the terminal. So it is very important to mention the type of chromosome type you're talking about based on the position of the centromere. And then you have to mention the arms, very important. After that, you have to mention its shape at the point of anaphase, and then draw it. We'll get all the marks. The next one still says differentiate between submetacentric and metacentric. So the first one lies much in the essay, but the second one is in the short answered. So because of the submetacentric, we talked about slightly above the middle, and then one arm is shorter than the other. So it is like L-shaped, J-shaped. Metacentric, it has to be at the center. The centromere is at the center. So makes the arms to be 50-50. Just draw, define. You'll get the 5 marks. Then another one talks about submetacentric, telocentric. Totally different. Above the middle, submetacentric. Telocentric, to the terminal. Don't even say towards. If you say towards in telocentric, it's wrong. It's to the terminal. Towards is acro. So we have to choose the kind of words we use to describe the type of the chromosome we are talking about. The other one is genes. 7 classes of genes. That is something we can do. We had pleiotropic, we had multiple, you have lethal, you had all those. Just define any. By mentioning and defining them well, you get your mark. So let us dive into Mendelian, because that is where we need the Punnett square. We need to understand the equations well. But what I have to remind you is, because I already did cut with the pharmacy group, and I'm trying to rectify a few places or a few areas where the marks could be reduced by 1, by half. The student might have got everything, but now, since we omitted small things, do you know the laws of Mendel? They still apply at the point we're talking about the Punnett square. When you're putting the Punnett square, remember the gametes. The male and the female should equally contribute their alleles. We are talking about at the point of gamete formation. You know, the 3 laws of Mendel, they matter. So if you don't tell me the male, this is the male, this is the female, even for the plants, there is that section up there. Put the male. Here, put the female. Before you can write anything. And then, if I define, let's start with the first one. We talk about, in border collies, we are at number 6. But now where it reads Mendelian genetics, monohybrid cross, I'm separating them. After the monohybrid, we go to another section. So after I'm done with monohybrid, we won't come back, only if somebody has a question. We are saying, in border collies, black coat, capital B will tell you it's the dominant one. Here I even explained, is a dominant to red coat. And I said, and I still have to repeat, in monohybrid cross, use only one letter. The cases, whether uppercase or lowercase, we will definitely know the capital one is the dominant allele. The recessive one will take the lowercase. So we are talking about a trait up there. Coat color. Put for me well, trait, coat color. Alleles. The letters have to be uniform. I'll tell you, use letter this, use letter this. Don't come with your S when we need to use B, so that there's no confusion. So if people should come into uniform, we have a letter. Here they are talking about B. But you have to start there by defining the trait clearly. Talk about the trait. Don't say color. Color of what? Coat color. After the coat color, come to the alleles. Specify alleles. We said alleles are the alternate forms of the genes. A gene controls a certain trait, but then contrasting characteristics. If it's for height, it's either tall or short. So it means this one is a trait for coat color. Put capital B, black. We already know it is black color. But don't put black and then you tell me dominant, recessive. What are you saying, dominant, recessive? No. I want the capital. I'll know, like a genetist, that one is dominant. Then get the same letter, but now the lowercase. We'll know it's the recessive one. Is for which color? Color red. Already, that one will give you mark. But if you don't give me alleles and you go straight without the traits, and you make a Punnett square, of what now? Which Punnett square are we making? We have to answer questions like bachelors in medicine or pharmacy. And then secondly, like a scientist, you know clearly what you're talking about until the end where you get the results or where you write the final answer. So clearly state the trait, the alleles, go to the Punnett square, place well. This is male, this is female. Now go back to the question. It says, a breeder has a black male. A breeder has a black male. Remember, the law of Mendel says, the law of dominance. It means this breeder or these breeds of what? Of dogs. Yeah, they dogs. They look like dogs. It's either a black which is heterozygous or a black which is homozygous dominant. Let's follow the story. The breeder would like to use the dog for breeding if he is purebred. You are even told if it is BB. It means the man has to be capital B, capital B. We talked about pure breeds. The woman has to be small b, small b. Pure breeds. Hybrid will only come in between when the two pure breeds, they mate. So we have capital B, capital B. If you have a paper, write, because it's going to help you. You can get back the recordings. They'll be saved on the channel, which you can use later. But if you have a paper, write. Capital B, the man, black. Pure, they're saying pure breed. Capital B, small b for the lady. It means the F1s will be all heterozygous. Let's look at the story. The breeder would like to use the dog for breeding if he is purebred or BB. You know, you have to show me the Punnett square for the pure breed. And there is a Punnett square for this question which is coming in. To learn this information, she test crosses. Remember what we said about the test cross. It helps you to identify their known genotypes. So at this time, they are talking about she test crosses him with a red female. Test cross. Test cross will come after we have the F1s. Remember, all the F1s are heterozygous. Now, you are at the second Punnett square because you want to see the F2s. The original breed was pure breed of these collie who have won awards. Purely black. They've said pure breed. We are going to get the hybrids, heterozygous, all of them. Phenotype, all alike. Genotype, all alike, heterozygous. Take that one. Test cross. Because it is F1s are as a result of this person who wins awards, the black one. If you do a test cross using the homozygous recessive, I had my pen. Where did I take it when I was standing to fix these things? So you have a test cross of homozygous recessive. Remember, when a test cross is done, I said it has to be specified whether homozygous dominant or homozygous recessive. In this case, if you take the hybrid, which are the heterozygous now, the F1s, and you do a test cross with homozygous recessive, what will come about? I think it will be half-half. Yes? It will be half-half. Will it be half-half? For somebody who has 50-50, you'll have heterozygous and homozygous recessive. If I'm not wrong. Let me get my pen. But the question says what? The breeder would like to use the dog for breeding if it's purebred. So give me a column for the pure breeding, where you get the heterozygous or the hybrids. Give me the one for test cross now. So the test cross, clearly mentioned up there. Male, female. What is the shape of telocentric chromosomes? Yes, I'll be able to read. Good. Mohammed Abdi has answered. It is rod shape. Glenn Kibe. Since the centromere is to the farthest, the terminal, you can't see. One of the arm is invisible. It is rod shape. Thank you. Mary Mugendi, yes. Good. We are here. As we learn, I'll be able to read, it's okay. I'll be able to confirm if whatever somebody answers is correct, but that one is correct. So well agreed. I can see Mary Mugendi says yes. I think it's yes because she is supporting what Mohammed Abdi has said. So the question says, draw Punnett square for F1 and F2. F1, where the hybrids are generated. Simple. Passing genetics is simple. The Punnett square promised us from day one. It's going to help us to solve the problems. And these problems are going to be solved from Mendelian to the population genetics of Hardy-Weinberg equilibrium. So it says, state the genotype and phenotypes of F1 and F2s. Simple. And I said, when you are mentioning genotypes, kindly say capital B, small b. Don't tell me the word heterozygous. No. The phenotype is what you can describe. And you know, the heterozygous one will show that the color for the dominant allele, it will mask the color for the recessive allele, so they'll appear black. Then the recessive are only expressed when it is homozygous recessive state. So they will show which color? The red color. That is simple. We are going to number 2. Abdi said we should maintain it at 1 hour, but I'm sorry of the hitches, but we are going to fix the time. Now, it says that a pea plant, we are at number 7. That's why I sent the questions, please. Let us follow together. Nobody should get lost, as I'm also going to read. I hope everyone can hear me. A pea plant is the F1 offspring. Look at that statement. Don't rush. A pea plant is the F1 offspring of true breeding plants. F1 offspring of true breeding plants with purple flowers, and a true breeding plant with white flowers. The plant is crossed with one that has white flowers, recessive. There, I didn't tell anybody to use a letter, but the ones who did it, because it was somewhere in the cart of the BPHARM students. So I tell them in the exam room, let us use letter P. If I forgot to put it, I say, let us use letter P. So it is up to you to put for me the capital P, but put a capital P where I can see it is capital, the dominant one, kindly. Don't be too mean with your drawing, especially the S's and the P and the C's. Make it very big. If it is dominant, it's dominant. Don't make them of the same shape of recessive. I keep on circling in red. What did you mean here? So put a very big P for which color is let me just go back for purple. For purple, let me be clear. Yes. Capital P, purple. Small p, white. And up there, start by trait. We are talking about flower color. Don't just say color. Color of what? Flower color. Trait is that physical expression, the phenotype. That's how you can describe it. You only have that chance. Remember, for the cat, it gives us another redemption point for the main exam. But now in the main exam, you have to hit things right. So be clear. You will get all your marks. I won't even deny you even half if it's yours. So the capital P, put a very capital P. Alleles, mention alleles. Capital P, purple. Small p, white. You'll get mark. Half-half. Imagine half-half. Half-half can change a lot of things. We are saying it is a result of F1 offspring. So you have to generate the 2 Punnett squares. And that is where the students were going wrong. They only generated 1 Punnett square. Not all of them. I'm trying to fix, as much as my BPHARM students are also on board, it's like I'm revising so that you don't make the mistake. So in this case, you're told is a result of the F1 offsprings. So you have to give the pure breeds. Give capital P, homozygous, dominant, homozygous recessive. But up there, remember even the plants, they have the male and the female part. So put male, female. We will give male purple. Female, we are always coming after this male. So we'll give ourselves white, no problem. Nothing is damaged. See, we are going to get hybrids there. Yes. So we want to see the F1s. If it's pure breed, all the F1s will come as hybrids. Then what do they say? This plant, they're talking about this plant, like they're talking about somebody whom they're seeing. This plant, this product of F1 from the true breeds is crossed with one that has white flowers. Is crossed by one that has white flowers. It looks more like a test cross. Homozygous recessive. Let me get my pen, because even if I'm trying to tell you that we have 50-50, I'm not going far. Yes, I'm right back. So as I'm trying to see that you already have all hybrids. You already have all hybrids, but then you have small p, small p. So you'll have capital P, small p, capital P, small p, small p, small p. So it means you'll have a ratio of 50-50. You'll have a ratio of 50-50. So the question says, how many of the plants in the next generation will have white flowers? 2 out of 4. Simple. Follow the rules. So there will be mark. The Punnett square for the parental generation, the true breeding, will give us 1.5. The other one, 1.5. This half, you are going to scoop. You see up there, trait, alleles. I'm going to scoop half until you get. So if you did make the Punnett square for the parental generation, minus 1.5, which is a lot of marks. Question number 8. I'm following them the way I sent them. The ability to curl your tongue up on sides, which means tongue rolling, is dominant to not be able to roll your tongue. It means right up there, trait. Start with the trait. Don't start with the alleles even. We have to know what we're talking about. Trait, tongue rolling. Capital T, I'll be able to tell you. Yeah, I was even now a bit better. Please repeat the quiz. No, Isaac, I sent. I'm not going to repeat the quiz. I sent the questions. Tell me which class are you? Are you MBCHB? Isaac, I want to help you. You can check the class email. Be it MBCHB, because I'm not going to repeat the quiz. I'm just going to say number 8. I sent. Isaac, can you check with someone? Did you people get the questions? I sent them on the class email, please. MBCHB, kindly. I sent to the class email. Can you access the class email? There should be somebody close, because if we are going to write the questions, it's going to be confusing, because you might write a wrong thing. I didn't understand the question. No, we are at question number 8. Isaac, I sent a Word document with the questions for the revision. Did you get it, Isaac? I want to see your response, please. They are in the class email, please. The MBCHB 2023. I just sent it at 8 for both groups. Fatma or Andizi or Victor, can you share with Isaac even on WhatsApp? Because we should just use the numbers. So number 8, it says the ability to roll the tongue. Roll the tongue. So if you talk about tongue rolling, good. Garama, thank you so much. Please just share with him. Just share with him. I think he realized that it is in the email. So he removed the messages. No problem. There is still time. So just share, check whatever you have in the email, please. We are at number 8. So give the trait up there. Tongue rolling. And then we say capital T. You can say able to roll a tongue or tongue rolling. Small t, not rolling a tongue or not tongue rolling. I'll understand the English, but the alleles, they should clearly show the capital, the dominant one, the small one is recessive. Then we are going far as saying a woman who can roll her tongue. A woman who can roll her tongue. The law of Mendel of dominance says this woman can either be heterozygous or homozygous dominant. Those are the two options. The story still goes. They are saying that a woman who can roll her tongue marries a man who cannot. So go to the Punnett square straight, please. Put the male. If the male is at the head, or you decide the female to be the head and the male to be this side, no problem. as long as you put the things right. So they are saying that the man can't roll a tongue. It means the man has no option but to be homozygous recessive. So we'll give the man small t, small t. What is the story about the woman? Does it stop there? A woman who can roll her tongue marries a man who cannot. Their first child, remember, they're saying their first child has his father's phenotype. We are saying by chance. The law of segregation. At the point of gamete formation, by chance. If one of the child has the father's genotype, it means that woman has to be heterozygous. You understand the point? So go straight and put the woman, capital T, small t. Simple. Because the father has to contribute an allele as the mother also contributes. Meaning, if the father do not contribute, where do the small t come from? The small t came from allele of not rolling the tongue from the father. So it means the mother has to be heterozygous. Then they're asking what? So after making the Punnett square, I think here you will score almost 3 marks for the Punnett square. Because 1.5, no, 2 marks. Because the trait goes for half, alleles half, and then the equations, the genotypes of the father, the child, and the mother, half each. So it means the difference will be accommodated by the Punnett square. So we go to number 9. If somebody has a question, kindly you just ask as we proceed. I'm trying to fix it so that we don't take much time, because Abdi already said that we need to take much time. Why is my questions on Google something? Let me see if I can open it on the desktop. Just a minute so that I can follow it. I'm at number, we are at number, yeah, I can. So we are at number 9. Please, we are at number 9. They're saying, create a Punnett square for cross between homozygous purple flowering plant and homozygous white flowering plant. What is the phenotypic and the genotypic ratio of F1s? Purple dominant over white, use P. That is simple and very direct. Just put the trait up there, color of the flower, capital P, small p. This one do not have a lot of stories. So it's just pure breeds. You are going to get heterozygous. You'll know how to answer the question. So this is too direct. But then they're saying it is the one which proceeds to number 10. A test cross of homozygous dominant done on F1s. What is the phenotypic ratio and genotypic ratio of F2s? So you can be told a test cross of the homozygous dominant with the hybrids or homozygous recessive of the hybrids. So it relates with whatever we already looked up there. Question number 11. A monohybrid cross on parental strains based on seed shape. Round, capital R, wrinkled small r as a trait, generated F1s which were all carriers for the trait. I think I didn't check, but then 12 and 13 relates to the question number 11. So use a Punnett square to conduct a test cross of F1s with homozygous recessive. I'm sorry, most of them are homozygous recessive, but even homozygous dominant, we can do a test cross. So what you need to do, I said, go up there, start with a trait. Here, the trait is seed shape. Don't say shape. Shape of what? Of human being, of an animal, of a plant. Seed shape. It doesn't cost you a time. It's only the 2 hours. Then you can get things right. Then go to alleles. Capital R, round. Small r, wrinkled. Very fine. Do your Punnett square. Place the male. Place the female. Go back to the question. What does it say? Monohybrid cross on parental stains based on the seed shape. Of course, round has to be dominant over wrinkled. But they're saying the F1s are all carriers. It means they are all heterozygous. So it means those are pure breeds. Simple. You'll describe the phenotypes as all alike. Genotypes, all alike. We are at X-linked. Then you do a test cross. So whatever you've done up there. So we are at X-linked. It says number 14. In a family, and now I'm even separating them. X-linked, autosomal dominant, autosomal recessive. We are now talking about monohybrid. We are done with monohybrid, of course. We are done with genes. We are done with chromosomes. So that when you recollect or you try to revise, you know this question was finding itself where? Here. A family. Father is hemophilic. Mother is a carrier. State how many sons and daughters are infected and healthy. I told you, and I'm going to repeat. If you see the table where they were listing autosomal dominant disorders, autosomal recessive disorders, do not put the sex chromosomes. No X and Y's. Put the trait, which stands for the disease, which is dominant, which stands for the disease, which is recessive. Go to the Punnett square. Don't put any XY or XX. Only in X-linked, like hemophilias, color blindness, DMDs, put XY, XX. And remember, Y do not carry any allele for the disease. Y is very special. Whatever touches Y brings infertility. Only excess. It means the man is either affected or healthy. Only the woman can be affected, can be healthy, can be a carrier, because both X's carry the alleles. Simple. Let's go back to the story. In a family, a father is hemophilic. Go up there. Trait, hemophilia. I said. And since it is X-linked, please don't go up there and put for me XH. No. I want alleles specifically. Put capital H, healthy. Small h, hemophilic. Because remember, as much as it is X-linked, it is X-linked recessive. None of them we discussed as X-linked dominant because they are rare. X-linked recessive. The disease is connected to the sex chromosomes, but at the same time, the allele, the disease allele is recessive. Put small h, hemophilic, capital H, healthy. Go to the Punnett square. The male, don't think I assume male is XY and the lady is XX. Give for me the male up there. You can even write male in words. You will still get it. If you can't remember the sign, is it the symbol of a male and a female? Give for me male, female. In this case, they're saying the male is hemophilic. It means it is X, small h, Y. And then they're saying the mother is a carrier of hemophilia. So the mother, X, capital H, X, small h. Meaning, the first box we will have a carrier girl. The second box we will have a healthy boy. The third one, meaning the lower one below the one which I had up here, totally hemophilic girl, and then hemophilic boy. I hope somebody has a paper and a pen. You'll reap very well if you're writing these things. Writing the Punnett square as I talk. So we are saying that family. State how many sons and daughters are infected and healthy. In the case of sex-linked, the hemophilias, The carriers will remain. You'll talk about carriers. But at the point you're talking about how many of the sons, how many of the daughters will give the disease to the next generation, even the carriers are counted because the traces of the allele for the disease are in them. Only the ones without the allele will not pass the disease to the next generation. So it means only in autosomal dominant and recessive, we talk about those ones are healthy. But here we're talking about the carriers. So we specifically say these are carriers, these are infected, these are healthy. So we are saying how many sons and daughters are infected and healthy. We have infected, one son is infected, one son is healthy, one daughter is infected, and one daughter is a carrier. I'm scrolling. If you have a question, just chat. I'm scrolling my questions. Yes. How many? A hemophilic family, I think number 15 is also still hemophilia. A hemophilic family involves a man who is healthy and his wife who is a carrier. So it's opposite whatever we had, meaning we will have a female or a girl who is healthy, a male who is healthy, a female who is a carrier or a girl who is a carrier, and a boy who is affected. So we will have a carrier, 2 healthy children, 1 affected. What does the question say? Draw a Punnett square. Correct, we've drawn. State the gender and number of kids who are healthy. The gender who are healthy, we have both male and female. The daughter is healthy. The son is also healthy. And how many are healthy and how many? 1 is affected, 1 is a carrier. The other 2 are healthy. So based on whatever you write, the Punnett square promised to help us. State the number of carriers. State the gender which is hemophilic. The gender which is hemophilic is a male, a boy. In humans, we are still on X-linked. There was a reason why I was separating these things, so that when you revise, it becomes easy. Remember, I told you that table which we are giving at the end of each of this. Huh? Who is this who is talking about dollars? Nilsson. Can you move out? I don't know what dollars is about because we are revising and trying to finish. Please, don't distract us. $3,000. For what now? Let us proceed. Don't mind. You know, when people see money, your mind will be diverted. Please, let us concentrate and finish because you still have tomorrow to revise in the morning. Now, I'm saying that if you look at the sections, now I'm on Duchenne muscular dystrophy, is also X-linked recessive. Most students were making mistake. When I talk about alleles, you already give me the X capital D, X small d. No, just give me capital D. Healthy. Don't give me positive, negative. That one is also wrong. Up there, you can even talk about DMD. That is a disease because the name is long. But then, at the point now when you're talking about the alleles, kindly. Capital D, no disease. Small d, there is disease. Disease is there. So it is X-linked, but then recessive. If you look at that table well, you will know the X-linked, you will know the autosomal dominant, autosomal. I can pick any. As much as I want the student to internalize, if this is autosomal recessive, how should my Punnett square look like? But you start with the trait. Down here, alleles. Each one of them, do a Punnett square. But before you can do the Punnett square, explain the males, the females. Very important. Very important point. You will know what you are describing. Not just throwing things left, right, center. No, let us be organized such that at the end, when you arrive at the answer, everything is well explained. Even for somebody who do not understand genetics, they'll be able to follow and know what you are trying to work on. So we are saying that it's a disease where muscles become weaker over time. The gene is located on the X chromosome and is recessive. At least here, I'm explaining much about it so that you can know how to put your Punnett square. So those afflicted with the disease die in childhood. If a female, that is now where the story comes, is a carrier of DMD, it finds when up there you've put for me capital D, small d. So now come to the Punnett square. The female XX is capital D, small d. The male, the gene is, if a female is a carrier of DMD, I'm on my book again. So the female is a carrier. The female is a carrier, is married to a healthy man. The man is X capital D, Y. Yes, the man is healthy. I told you Y is not touched. Don't touch any Y. So it means by chance, the first child as a girl come out to be free of the disease. Capital D, capital D. The boy turn out to be free of the disease. But there is a girl who is a carrier here and a boy who is fully infected. What do they say? What percentage of our daughters will inherit the disease? Percentage. Do you know the carrier? They have the traces, the X small d. The traces of the disease is there. 25%, 25%. Yes. We talked about the heterozygous. We talked about the natural selection. Selection type. You can't do away with the heterozygous because the traces of the allele, recessive allele, is still there. So for the DMD, the carriers in a heterozygous state has the allele for the disease. So they're also going to, what are they asking? They are going to transfer the disease or what? They are going to inherit the disease because it's going to be passed on to the next generation. The last one under X-linked. Colorblind is also X-linked recessive. A man is colorblind. Go up there, tell me trait, colorblind. Give me a very capital C and say color, no colorblind. Small c, colorblind. I repeat, capital C, healthy. Small c, colorblind. Come to the Punnett square. The study says, if a man is colorblind, meaning the man is X, small c, Y, and is married to, what percentage of his sons will be colorblind? Assuming the mother is not a carrier, meaning the mother is healthy. We are up here. X, capital C, capital C. X, small c, Y. It means the first option, the girl will appear carrier. Two girls, carriers. Boy, healthy. Boy, healthy. Imagine the boys are coming healthy. What I'm drawing. The girls are carriers. So what are they saying? What percentage of our daughters will inherit? No. What percentage of his sons will be colorblind? 0. Sufuri, 0%. Autosomal dominant. I'm moving. Abdi, I'm trying to manage the 1 hour time. The good thing is some will now seem to look as if they are repeated because we already discussed them in the previous one. So if you are talking about the X-links, now you know the pattern, what you need to write up there. If it is homozygous, autosomal recessive, autosomal dominant. So you need what to write. Start with the trait, alleles, Punnett square. So I'm at autosomal recessive disorders. Autosomal dominant. You know, these are my equations. They appear and then they disappear. So I have to so we are talking about autosomal dominant disorders. Heterozygous male for achondroplasia. If you look at the achondroplasia, it was falling under the autosomal dominant. Mates with unaffected female. Unaffected female. Using A for list. Using A, list the number of affected and unaffected children. You can see there, I don't stress on the gender because it is not sex-linked. I don't stress on the gender. I stress much on the number of the children who are affected, still based on the Mendelian law of dominance. So, a heterozygous male. So, if we use a capital A, heterozygous, small a, for male, up there, you can write male or female, and then we are saying unaffected female, unaffected. It means the female is homozygous recessive. Small a, small a. Remember the capital A is for achondroplasia. Small a, no disease. You have to specify it up there clearly. Don't put X and Y's. These are autosomes. We learned about the sex chromosomes and autosomes when we are introducing chromosomes. Don't put X and Y. Immediately I see X and Y, I give a very big wrong. I don't even look at anything. Only if you get marks up there for the traits and alleles. So don't put X and Y. These are autosomes. Yes? So we are saying the female is healthy. The female is healthy. We are getting 50-50. 2 of the children affected, 2 unaffected. So they're saying list the number of affected and unaffected. 2 children affected, 2 children unaffected. Autosomal recessive, a woman heterozygous for sickle cell. Remember they said both parents have to be carriers for the autosomal recessive because the disease will express itself in homozygous recessive state. By chance, 25% will get affected. The other 75 are healthy. The disease, where the sickle cell anemia falls, the PKUs, the thalassemias, the cystic fibrosis, the allele for the disease is recessive. The allele for the healthiness will suppress the allele for the disease. And these individuals who are in heterozygous will not show any symptoms. They are asymptomatic. Only the ones who are homozygous recessive. So we are at a woman is heterozygous for sickle cell anemia. We will use capital S, put a very big one for healthy. Small s for sickle cell anemia. Trait there, sickle cell anemia. Put clearly the traits. Go to the Punnett square. Put the woman. It's always a symbol of like a plus down here. Then the man looks more like an arrow. So we are saying that with heterozygous male, using S, list the number of affected and unaffected. That one, even before I can cross it, I know the affected is 1 out of 4. 3 are unaffected. It means by percentage, 25% affected. In humans, cystic fibrosis as well is caused by recessive allele on chromosome number 7. A person must inherit 2 of the alleles to have the disease, meaning have to be homozygous recessive. What are the chances of having a child having the disease if both parents are heterozygous? So both parents have to be heterozygous. The chance of the child having the disease is 25%. Probability, 25%. 1 out of 4. Simple. Single gene disorders, these ones you know. 2 Mendelian disorders, and give any 3 example of the disease in each case. So if you see this one, it has to come in essay. You can either discuss autosomal dominant disorders, autosomal recessive, and mention the characteristics. You take any 3 diseases. You give a scenario in autosomal recessive, where the 2 parents are carriers. Autosomal dominant, where one of the parent is healthy, the other one is heterozygous. So you can even pick the X-linked, but you have to give the characteristics for you to earn a mark. And also you have to give a Punnett square to show the example, any 3. Then for the chromosomal disorders, we talk about short notes on Klinefelters. You know the Klinefelters, these are the people who are born as, they're biologically men, but due to addition of an extra X, they look more like females. They develop the characteristics of a female. We saw the characteristics, but this is a result of non-disjunction. Yes, so you have to mention the reason more than the characteristics. Don't rush in the characteristics of having hips and breast and infertile without explaining what brings that one. So they're the ones who have the 47 instead of the normal 46, because there is an extra X. You know, X relates much with the female characteristic than the male. So they behave more, or the characteristics show more of a female than a male. Then the Turner syndrome. They are born females, but they have the characteristic of males. But that is because of deletion. There is only one X instead of the 2 X's. So if you talk about the chromosomal disorders, remember we said these are the mutations which happen at the DNA level. We had the 2 classifications, so they're the third one of multifactorial. Most of the factors which contribute, but we didn't look at that. We looked at the chromosomal disorders and the Mendelian, which are the single gene disorders. So the chromosomal, we said, where the cri du chat were, where the Down syndrome were, where we have the Klinefelters, where we have the Turner syndrome, there is a mutation, a deletion, addition, remember. So you can describe any. You talk about the chromosomal disorders, the Turner syndrome. Let's go to dihybrid cross. I'm trying to save time, then I can look at Hardy-Weinberg, especially the calculations. I know people are already tired, but let's concentrate just for a while. Even me, I'm tired. My day was very, very, very busy, but we have to work. Now, when we have the dihybrid cross, remember the law of Mendel, which we are talking about, is the independent assortment. 2 traits are involved. 2 genes. At the point of segregation, they independently segregate. The gene which controls the color do not depend on the gene of the height. That is what dihybrid was coming in handy for. It will describe the law of Mendel, which is the law of independent assortment. Go up there and state for me traits. Here we are talking about a gene A controlling the fin length. Talk about a fin length. If it's gene A, it is write the A. Capital A will be for the short fins. Small a, long fins. Fin length, trait number 1, the gene controlling the alternate forms of that gene. Those are the alleles. Gene number 2, it is what? Fin color. It's either gray or lemon. Fin color. Capital B is for gray. Lemon, small b. Get mark. Half, half. Half-half. Not much, but half-half. You'll get 2. I said, after mentioning that, generate the gametes. The next question which will be asked is gamete combinations. And I said, in this case, you have capital B, small b, capital A, small a. It's not even showing. This is brown. Capital B, small b, capital A, small a. Gamete combinations, BA, capital B, small a, capital A, small b, small b, small a. Gamete combinations. Gamete combinations. Cross them. Cross the capital B. Go with capital A. Next, capital B, small a. Small b, capital A. Small b, small a. Then you'll have gamete combination of this. You'll get 2 marks. Nothing much. This is what you explain on the Punnett square. For the male and female, remember they equally contribute. This is what you put here. This is what you put. I told you don't complicate life. Don't complicate life. Complicating life is not good. It is not healthy. I think it's a lot of reflections. Yes. You see? The gamete combinations. Put them in the matrix. Now do well. You'll find capital B, A. Very easy. You'll get a phenotypic ratio of 9:3 to 3:1. You get your 10 marks without even struggling. In pigeons, you know, here talks all about dihybrid. The way I've tackled the one, you tackle all like that if you see any of them. In pigeons, a dominant allele C causes a checkered pattern in feathers. Feather pattern. Trait up there. Dihybrid cause. 2 traits. Feather pattern. Capital C, put checkered. Small c, plain. Is it that difficult? No. Feather color. The second trait. That is the second gene controlling. Remember, they segregate independently. Feather color do not depend on the feather pattern. The feather coloration is controlled by independently assorting gene. Dominant B, red feathers. Capital B, red feathers. Small b, brown feathers. Feather color. Generate gametes, the way we've done with the previous one. You get your point. Then go to the Punnett square. Very easy. You will get all the 10 marks. I'll not even go with even a quarter. I'll give it to you, all of it. The law of Mendel. Explain the law of Mendel. Type of cross. No, this one I can't set. The direct ones like this one. This was the time when now you're introducing students to genetics. Maybe it's the second time you're teaching or the first. You don't want to make life complicated. No. It is the type of cross used. Mendelian law. Using the above law, tall plants. No. Flowers in the farm. So it applies to all, please. Under dihybrid, just go and practice. If you didn't get it right, then just go and practice. As you take the video, you'll be able to know by examples. You'll be able to get everything. Put the alleles, the traits, each one of them, the alleles, gamete combinations. If you get the gamete combinations right, my friend, the Punnett square will be flowing until you'll be smiling. Now, what is Madame setting? Because you are fully prepared. And now you are getting all the concept. We are at population genetics. We are almost there. Population genetics, we are at, I didn't want to start with chi-squared, but I'm going to start with it anyways. The chi-squared of fitness test. With the last lecture on population genetics, we talked about the evolutionary forces which are working on our Hardy-Weinberg. Remember, Hardy and Weinberg said the genotypes and allele frequency should remain constant in the coming generations if some conditions are met. And those conditions were the population should be large. Because if the population is small, my friend, fragmentation, there shouldn't be any migration. There should be random mating. Don't choose whoever you want to mate with, whether brown or dark. Don't. You are going to interfere with the allele and genotypic frequencies. There shouldn't be any selection. You could see the effect of selection. And then the last lecture we did, we looked at each of the evolutionary forces, how they affect the genotypes, and at last affect the allele frequencies. So the chi-squared of fitness test was the one which was used to detect any of the evolutionary forces which are working on our population. Looking at the degree of freedom of one, because in a biallelic, we are talking about two alleles, is either tall or short. Degree of freedom of one, we're having our value at 3.84. If it was exceeding 3.84, I said reject the null hypothesis. The population is not in Dihybrid equilibrium. So for you to test the presence of each of the evolutionary forces, we were looking at the ratio of the genotypes 1 to 2 to 1. If the heterozygous go more than 2, mostly selection was coming handy. That is what we saw. So what we also saw with the chi-squared of fitness test, you have to start by looking at calculating the genotypic frequencies. Then you go to allele frequencies. Now you know how to calculate the genotypic frequencies. Very simple. Each of those genotypes over the total number of people in the population, you'll be getting each of the frequencies for the genotypes. Then the allele frequencies, I said, the genotypic frequencies, be it homozygous dominant, heterozygous, and homozygous recessive, they should add to 1. Same with allele frequencies. P will stand for the dominant allele. Q will stand for the recessive. P plus Q should add to 1. For you to get P, you need P squared plus half the heterozygous. For you to get Q, you need Q squared plus half heterozygous. Then the chi-squared test was saying, you know the observed, the raw data, heterozygous, the homozygous dominant, the homozygous recessive, each one of them do observed minus expected, because expected you have to calculate using the allele frequencies which you already have, times the number of people in the population, you'll get expected. Observed minus expected squared over expected for the homozygous dominant, for the heterozygous, for the homozygous recessive. The totals of all these genotypes should be within 3.84. If it's be above that, then definitely the population is not in Dihybrid equilibrium, meaning there is an evolutionary force working on our population, but if it is within the 3.84 or below 3.84, then the population is in equilibrium. That's how simple it is. So the formula of chi-squared, observed minus expected squared over expected plus observed for the 3 genotypes. That one we saw. If it's above 3.84, because we are biallelic, say not in equilibrium. The forces are working on it. Simple. Same with these ones. You can see the degree freedom of 1, 3.84. And I say tomorrow, don't ask for calculator. I'm not going to give you, madam, can he help me? No, we are not going to pass calculators. If you don't come with the yours from the first minute, wait 2 hours. Because that one you are not serious. I started talking about it long time ago. Carry your calculator. Even for BPHARM students, during the exam, during Cat 2, calculators we need to have. Because we are going to calculate. Population genetics we have to calculate. You can imagine you have to calculate the chi-squared or the multi-allelic system. And then somebody is still asking, hey, I'm still using. Whose time will you waste? No, carry your calculator. Even now, just go to your neighbor next door. Tell them, if you have a calculator, kindly help me. Multi-allelic. We are talking about the ABO blood group system. How should we calculate given the genotypic ratios or any of those alleles which are given? So we said, for example, in a population, 800 people, 200 are blood group A type, 25 are blood group B. Calculate the alleles and the genotypic frequencies. Simple. Let A, blood group A, take the P. Blood group B, take the Q. R, we were giving O. Do a Punnett square. We'll have the genotypic combinations of 6 of them. P squared to PQ, Q squared to QR. Yes, let it add to 1. So what you start with is here, these people are showing squared. So like whatever you are seeing in A, 200 over 800, find the square root of whatever you're going to get there. That is how you'll get P. Then for the B, you'll do 25 over 800 and do square root. You'll get B. But for the PQR, they should add to 1. So you have to minus the total of the 2 which you get. Then you get for R. Then go and substitute 2Q, 2QR, 2QP, or 2Q what? Yes, substitute. You will get the genotypic frequencies for each of those. That's how simple it is. But remember, you have to get the square root, because those are Q squared or those are P squared. They are R squared, but you need R. Yes, that is the point. So it will even apply for the next one. Hardy-Weinberg assumptions. A few of the equations which will not need calculation can also be brought. Like, discuss the effect of small population size on Hardy-Weinberg equilibrium. Don't go round and round. I told you the effect of small population size. Go straight and explain about the 2 patterns of genetic drift. It's either bottleneck or founder effect. So you have to explain the 2 patterns. And I said, for bottleneck, any calamity can hit. It could be floods. It could be corona, the way it was. But then, there are few survivors. Of the few survivors, there are people who can be having allele for any of those diseases, so that when the population grow again, the new population, its genotypes or the alleles will be determined by the survivors. Because these people have to mate. Inbreeding will come handy. So the effect of the population size, bottleneck, then there is founder effect. Small people moving out from a large population, they go and settle in a small area. Then they start mating because the population has to grow again. But then the new population, the alleles and the genotypic frequencies are going to be determined by the founders. You saw the example of Felder's disease, the one where we have the 6th finger and the heart defects. To date, 1 out of the 200 have it. If you calculate, you'll get that it's the highest. Yes. Then, write short notes on selection model where both homozygous dominant and recessive are selected against. Go and look at the selection model of sickle cell anemia. It fits it well. Because I said the falciparum will go for the normal HB. So it means the homozygous dominant will die of malaria-related conditions. Homozygous recessive will die of sickle cell-related. They'll be anemic. So the ones who will survive are the heterozygous. So in case where the homozygous dominant and homozygous recessive are selected against, heterozygous are selected for, it fits well the sickle cell anemia as the disease which relates with that model. It also says, discuss how a selection model where heterozygous are selectively disadvantaged works. Selectively disadvantaged. The heterozygous are removed. They have a fitness value of 0. They can't represent their genotype in the next generation. The best example was that one's for the rhesus factor. Mother being rhesus negative, the child coming out rhesus positive, the child will not survive. Lastly, discuss a selection model where the homozygous dominant is selectively disadvantaged. The CCR5 gene, which gives immunity for HIV, the homozygous recessive will survive. They have both the mutant 32 base pair gene, the CCR5. The heterozygous, partially, they will have partial immunity because they have allele for the mutants and the normal one. Only the homozygous dominant do not have. They will be eliminated. They will have a fitness value of 0. Simple. Inbreeding coefficient, we are almost. I'm happy that people are still there. I'm almost. Tomorrow you'll smile, my friend. Tomorrow you will smile. Just be attentive. Madam can't revise all this and then you miss something. Not in my case. As long as I've explained how we are going to answer, my friend. Let us see. Inbreeding coefficient. We saw inbreeding as one of the patterns of non-random mating. Remember we said inbreeding will add more of homozygosity. And in inbreeding, people mate who are genetically related. It means it could be even among the cousins. So homozygosity will increase. But then we said we can calculate if the population is inbred or not by looking at the inbreeding coefficient F, which is equals to 1 minus observed over expected. If the inbreeding coefficient, the F, is greater than 0.5, we said the population is inbred. But if it is less than 0.5, the population is heterozygous. It is not inbred. Simple. I told you, don't make life difficult. Here, what you have to do is simple. You have to look at the heterozygous. We are concentrating on heterozygous. But even before you concentrate on heterozygous, you have to start by looking at each of the genotypic frequencies, because that's why you've given there, so that you can get the allele frequencies. The allele frequencies is going to help you to calculate the expected heterozygous, because it says observed heterozygous over expected heterozygous. You minus 1. So for you to get expected, you have to get the genotypic frequencies first. Then you can get the allele frequencies. If you have the P and Q, multiply 2PQ times the total number of people in the population, you'll get expected heterozygous. Then put over observed. Observed is the raw data here. It is 40. Then, if it is above 0.5, say it is inbred. If it is less, not inbred. Same with number 12. It's the same. Calculating heterozygous. We are finishing by that. If you have to calculate the heterozygous, what do you have to do? That one which somebody can't. You see, that one which you have a problem in doing. People are rolling their tongues, but you can't. People are passing, but there is a group which can't pass. That group which can't pass is what we have to concentrate on, so that we can know how to help. That is why the heterozygous is there. We have to know, for genetic counseling, this group which still have the traces of the allele for the PKU, for the cystic fibrosis, should we know the number of the people in the coming generation who will carry the allele for the disease? If in any case that person who is heterozygous marries another heterozygous, then it means the allele for the disease will continue to exist. That lethal allele will still exist. So it is good to calculate the heterozygous. Let's start with the first one, but I will not discuss all. I'll just choose a few. So the ability to test thiacarbide, whatever, P is for what? Polythiacarbide, is due to a single dominant allele T. You sample 250 individuals. The total number of people in this population are 215. And determine that 138 could detect the beta test. We are not interested with the 130, with 138. Those ones do not have any problem. We are having a problem with the people who can't test. Those are the people we want. So don't go and put 138 over 215. What I want you to put over 15 is the 215 is the people who can't test. Put the 77 over 215. That is Q squared. We are looking for that recessive allele. That allele which is making people not to be in the normal side. Those ones who cannot test, we are interested much in them. The people who can test, we don't have any problem. So you are given both so that you can get confused. Can I do with the 138? Where are we taking the 138? 138 are people who are normal. They can test. But these ones who can't test, they are the Q squared. So it means for you to get Q, do a square root of 77 over 215. The square root, you'll get Q. After getting Q, subtract 1 from the value of Q, you'll get P. Then you'll be able to answer the questions next. They're asking expected genotypes. Allele frequencies, you already get them. Expected, expected is simple. If it is for the genotypic frequencies, the P squared, you do P squared times the total number of people in the population times 215. That is the expected genotype. If it is heterozygous 2PQ times 215, if it is homozygous recessive, it is Q squared times 215. But you have to start by getting the Q so that you can get the P. So you have to do square root for the heterozygous. Based on how the equation is, you'll have to tell whether it is for getting the square root or not. So it is you to choose. 9% of African population born with severe sickle cell anemia, SS. What percentage of people will be more resistant to malaria? You get? More resistant to malaria. They want you to calculate the heterozygous. But you have to start from the 9 over 100. Find the square root of 9 over 100 so that you can get Q. After getting the Q, minus 1, you get P. 2PQ. That is heterozygous. That's what they're asking. Who is resistant to sickle cell, if not heterozygous? Homozygous recessive? Homozygous dominant? Heterozygous. They're asking if you can calculate the heterozygous. And they're saying, assuming it is in Hardy-Weber. That one has to be added because we are talking about the constant. The constant, what? The constant value of the genotypes and the allele frequencies. Allele T for testing, I think that one looks more like the other ones. So those who cannot test, that is what we want. I have one which talks about the rhesus factor and one where I like this one. Let me tell you this. There are 100 students, number 18, in a class. 96 did well. We are not interested in the 96 who did well. We are interested on the 4% who did not perform. Please. They're saying 4 blew it totally and received a grade of F. Sorry. In the highly unlikely event that these traits are genetic. They're saying in likely. It could be likely that it could be genetic. Maybe they inherited from the parents. They're saying likely. Or environmental factors can contribute. Maybe the student was exposed to some difficulties. Maybe they were traveling long distance. Maybe there were no teachers. So you can't. So they're saying unlikely it could be genetic. Then what happens? rather than environmental? If these traits involve a dominant and recessive allele, and if the 4% represent the frequency for homozygous recessive, calculate the frequency of recessive and dominant allele and the number of heterozygous. We want 4%, 4 over 100, find the square root, start from there, simple. Don't do the 96. We don't need the 96. I'm going to do the other one and then we can go. There is one which says the rhesus factor, RH, in the ABO blood group system is independent. In humans, RH plus individuals are having RH antigen on their blood cells. RH minus individuals do not have. We are interested in the RH minus. They are the recessive. Put over the total number. Do square root. Get Q. Minus 1. Get P. Do the 2PQ. Q squared. P squared if you are asked the genotypic frequencies. Thank you so much for your time. And God bless. I hope it will help. And tomorrow we can prepare well for the CAT, which is for MBCHB is more or less like an exam. So all the best. Tomorrow, God willing, let's meet at 10. BL5. BL5 is that hall above, equip. If you are almost to the lab, the pharmacy labs, and then it is it beside or directly? No, that is not directly opposite. Yes, towards the pool, that building. Up there, BL5. That is where I booked. So let us meet there and bring my assignments tomorrow, handwritten. So have a good night. Thank you for your time and may God bless. With time, you're going to see it on my YouTube channel. Anybody can go and revise using the video. It will be of help. Thank you and may you have a good night.